Okay, so today we're kind of transitioning to a new organ system in the body, the skeleton. So yeah, I always love to start again with some fun facts about the skeleton. And so average skeleton's about 30 pounds. Okay. We shrink about a quarter of an inch every day. And then as our intervertebral discs kind of compress down, and then we gain that height back again when we sleep, and we get that height back. The wild thing to think about our skeleton is we kind of tend to think of it as just this like these like rocks inside of us that don't really do anything. They're not really dynamic. They're just kind of there, but it's super dynamic. Our skeleton is changing constantly, so much so that it's brand new every 10 years. None of the tissue that was there 10 years ago is still there at this point. And so it's constantly being broken down and replaced and remodeled based on the stresses that we put on it too. And that's one of the amazing things. The skeleton is very adaptable based on the stresses that we put on it. So yeah, and then we kind of have this ability to vary the thickness and the stiffness and the flexibility of our bones, all based on kind of the components of the bones. And we'll talk about the kind of collagen inside a bone that really gives bone its elasticity and its kind of ability to flex, but then also the really hard part, which is the calcium phosphate salts that give it the real firmness. And we can, yeah, do incredible things with our bones, and animals can do even more incredible things with their bones, like run into another animal at 25 miles per hour and not break their head. We couldn't do that, but they can. So, yeah. So this is just kind of an overview of what the skeleton, sorry, I think I need a sip of water. There's an overview of what the skeletal system is made up of, right? So it's not just bone, but we do, as you guys have been studying, the bones of the axial skeleton, the bones of the appendicular skeleton, and then we've got all the cartilage. That's considered part of the skeletal system too. You guys have seen these in the slides, right, with our histology stuff. So hyaline cartilage, elastic cartilage, fiber cartilage, all of that together is what makes up the skeleton. Okay, so quick kind of question here. Sesamoid bone, what is that? Any idea? Check with the people on your team, see what you guys think, and send that in. And then see if you can think of an example if you know what it is.
Tendon would be muscle. Cube is gotta be boiled.
Bro, I learned it in high school. I don't know, but
Like compression, I feel like this always.
All right, send in your answer if you haven't yet. All right. A couple more people, I think, need to send it in. So about half of you are saying A, then about a quarter of you are saying D, and then the other quarter are between B and C. So a sesamoid bone is a bone that's encased in a tendon. Yeah. Yeah. So any examples? Can anybody think of examples? Yeah, what do you got? Patella, yeah, your kneecap, right? Your kneecap's a bone. What's another one you guys have learned in lab? Huh? What's another example? We got our patella. What else? This little guy here. What's this little bone that sticks out right there? Your pisiform. Your pisiform is a sesamoid bone too. You have one of your wrist flexor tendons that goes right through it, right? That's why you can kind of move it around, kind of like your kneecap. You take that little one like right where your wrist creases right there, and you put your thumb right there. You kind of move it around. That's just like your patella. Same idea as your patella. You have them underneath your big toe as well, and underneath the head of your first metatarsal. You got two of them right there actually that go your big toe flexor tendons go through. So yeah, got a bunch of them around the body, but that's what it is. Okay, questions on that? Okay, so that just kind of gets us into this idea of classifying bones, okay? Bone classification by shape is kind of the common way to do it. And so we have really four categories. So long bones, short bones, irregular bones, and flat bones. Okay, so why don't you just take a guess here and match those up with the letters that you've got there. It shows an example for each. Take a guess at what you think, and then which one do you think would be the irregular one out of these four options here?
Yeah. I have a unrelated thought.
Okay.
You didn't have a reading quiz on Monday, right? Yeah.
Anytime there's a TBL day, you don't. Yeah.
I was thinking that I was missing it.
Yeah.
No, thank you. He goes up.
All right, send in your answer here. You're sending in which one is the irregular bone right here? A, B, C, or D? All right, about four more of you still need to send it in. All right, anybody else? Okay, so it looks like about 3/4 of you are saying B, that vertebrae there. So let's take a look at these. So A would be our long bone. That one's pretty obvious. All right, B is the irregular bone. So good job. Most of you said that. Okay, and then C is an example of a flat bone. Okay, and then D would be example of a short bone. Okay, so just kind of one way to classify bones. And yeah, so then some more examples. Give you a sec to finish writing that down. Okay, so some more examples of each of these. So pretty much all of our limb bones, ones in our arms and legs, minus the carpals and tarsals and patella, most of those are long bones. So even like our metacarpals and metatarsals and phalanges, those are still long bones, even though they're kind of short. Yeah, actually that's wrong. There's the oh, never mind. I'm confusing myself. Not sure why, but carpals, tarsals, and sesamoids would be considered the short bones. And we already said what a sesamoid bone is, right? A bone encased in a tendon. Yeah, and then flat bones would be the cranial bones, the ribs, the scapula, and then vertebrae, os coxa are just the ones that don't really fit into any other of those categories. So they'd be the irregular bones. Yeah, go ahead, Nicole. Yeah, those would be I'm pretty sure those are kind of a separate category completely. If anything, we'd probably put them in the irregular, but they're very, very small right there. It's very unique bones. You should Google it well, if you don't have a device, so don't take your phone out. But my guess would be they'd probably fall in the irregular, but I don't know. They might just be a total different category because they're so unique, right? Yeah. Kayla. Say that. Ask that one more time. I just wrote down the definition that we already had for a sesamoid, which is a bone encased in a tendon. Yeah. 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 Yeah, Karen.
I just saw. Never mind.
Okay. All right. Okay. So let's talk a little bit about, well, actually first, this is the sesamoids these are the sesamoids I was talking about on the base of our first metatarsal, right before our big toe. Those are just some more examples of sesamoid bones right there. Okay, so functions of bones. Bones provide all of these different functions, right? So protection of our bodies. What do you think of there? What's an example of a bone that might protect a part of our body? Ribs, skull, yeah, for sure. Vertebrae, our spinal cord goes right through our vertebrae, right? Yeah, so definitely you could say all of that. Ribs, skull, vertebrae. Okay. Support, that's just kind of all of them, right? Most of our bones are providing some level of support, and cartilage does that too, right? Cartilage is always going to be found in our joints, helping make our joints move smoothly, but also helping hold our joints together in some cases, providing some cushion between bones, things like that. So that's all related to support. Movement. How do bones help us move? Okay, they articulate with each other. Nico, what are you gonna say? Yeah, if we didn't have anything hard for muscles to pull on, then our skin would just kind of like smash together. You need a hard lever to pull on, right? We got these muscles that are incredible and they're strong and they can exert a bunch of force. But if they didn't have a hard lever to pull on, that wouldn't really do much good for us, right? So we need those hard levers, and that's what the bones do for us, right? So provide a lever for muscles to pull on. We don't necessarily always think of this function, but this is where all of our blood cells are formed in our bone marrow, right? So that includes red blood cells, white blood cells. They're made in our bone marrow. Okay. And then mineral storage, right? So obviously calcium is a big one, but phosphate as well. And we're in a state of constant turnover of calcium phosphate salts in our bone. And calcium is one of the key ions that helps control our nerve function, our muscle function, many different functions, many cellular functions. And so the level of calcium in our blood needs to stay really consistent. And if it doesn't stay really consistent, then we're in trouble. Nerves stop working, muscles stop working. And so we're constantly able to pull calcium out of bone when we need more and put it back into bone when we have too much. So these are just some general functions of bone. Questions on any of those? Okay, so the different tissues we find in a bone include both spongy and compact bone. So these are kind of two different types of bone that we find in our bone. Okay, the spongy bone is always on the inside, so that's the stuff in there, right? And then the compact bone is the more dense stuff on the outside. Okay, and so that's always the external bone. Okay, so the spongy bone is still hard, but it has lots of cavities in it. So we can put blood vessels in there, we can put bone marrow in there, we can put lots of different stuff in there. And it's a little bit lighter, right? If our bones were just fully solid compact bone, they would be a lot heavier. It wouldn't be very flexible, and we wouldn't be able to put other things in there like bone marrow and blood vessels and things like that, right? So there's some functions there of that spongy bone. And then the compact bone is what gives us that strength and rigidity on the outside of our bone that we need to make it as supportive as possible, right? And so we can kind of see if we take this bone that's been chopped here, we can see the compact bone on the outside, the spongy bone in the middle, and then we can see the marrow too. Yellow marrow is really just fat. It's kind of a storage site for fat. And then red marrow is where all those special stem cells are that help us produce all the blood cells of our body. Yeah, go ahead.
Very different color that.
Which part?
The
Inside here? The whole thing, yeah. Yeah, it is very bright red, and that is because we have blood in there. That's really what the color is, and so in particular, arterial blood is going to be when it's oxygenated. So I don't know exactly how this image was prepared and how this tissue was prepared for the picture here, but yeah, we do have blood, but then we also have blood producing cells in here too, and so there's just a ton of capillaries in here, right? So lots and lots of little blood vessels. In bone? Yeah, good question. Other questions? Okay. All right. So then when we look at a long bone like this, we can kind of get at some of the other structures that we find in bone. Okay. So one of those is we always have cartilage associated with bone. Okay. So hyaline cartilage, we're going to find on the ends of our bone, right? So type of one place we find hyaline cartilage is in the articular cartilage. Okay, so that's on the ends of our bone, nice and smooth, nice and hard, so it makes that nice surface for our joints to move, right? We'll find elastic cartilage sometimes around bones as well, and then fibrocartilage, right? These are like our menisci and our knee, other menisces and other joints as well. So those are all associated with bone. We have a connective tissue layer on the outside of our bone called the periosteum, and we can see that right there. So the periosteum is, yeah, just a connective tissue layer that kind of covers the bone, serves as kind of a housing for blood vessels and nerves. Okay, so lots and lots of nerve fibers. And this tissue is another example of dense irregular connective tissue. And so we'll talk about tendons later, but a tendon's function is to connect a muscle to a bone, right? And when a tendon connects to this bone here, it's just going to weave itself right into the periosteum of this bone, right? So it's just kind of like incorporated right into that periosteum, and that's how it binds to the bone. Okay, and then we've got yellow marrow. As I mentioned in adults, we would see yellow marrow in the middle of our big bones like this. And the middle of the bone is called the diaphysis. Okay, we'll see these names again later too. But the center, this kind of big part in the center here is called the diaphysis. And so in long bones like this in adults, the diaphysis is full of yellow blood marrow or yellow bone marrow, which is fat. It's just a fat energy storage site. But in kids, this would all be red bone marrow because we've got to produce a lot more blood cells in kids because they're kind of building up their whole supply of blood cells. Okay, so the function of yellow bone marrow is energy storage. Okay, function of red bone marrow is to make red blood cells and also white blood cells. So really, all of our blood cells are made in our bone marrow. So in adults, we would just have the bone marrow up here, the red bone marrow up here, and then yellow bone marrow in the middle, and we'd have some more red bone marrow down here in the end of this on that side too. Yeah, you go.
Yellow bone marrow, like he's tired.
Yeah, it's just, I mean, it's converted to a different type of tissue, but it's more just in the location where that red bone marrow used to be. So yeah. Yeah. Good.
See the red apple, it's called the red blood cells into white blood cells.
Yes, I should also say WBCs, which are white blood cells. Okay, red blood cells and white blood cells. Yeah. Okay, other questions on that? Okay. All right. So take a sec here, chat about this question with your team, and send in the answer you think is right.
Okay. Thank you. See that.
Yeah, but.
Yeah. Yeah, I just don't know.
All right, go ahead and send something in here. All right. A few more people need to send it in, but I'll leave it open. We got about 40% of you saying E, about 25 C, about 30% saying B. So again, bone is made up of both collagen, which is a protein, which is softer, has some flexibility, and then it's made up of those salts too, those really hard and rigid salts. Okay, we can't really the salt part is not flexible at all. Okay, and so part of the flexibility is the collagen protein fibers, and then the other part is this interesting thing that's been discovered that they have these bonds that hold the protein fibers together, and they're called sacrificial bonds. And they actually can break and then reform. And bones are quite flexible, actually. Your bones can bend quite a bit before they break. And that's helpful, right? Obviously. So yeah, so both C and D would be how bones get their flexibility. Okay. All right. So let's talk about those components of bone. So what we would call the organic components make up about a third of the total matrix of bone. Okay. So this includes the cells. We'll talk about the names of the cells here in a second. But then also in all, remember bone's a connective tissue, right? In all connective tissue, we have something called ground substance. Ground substance is like the stuff around the cells, right? What it's like, we got the cells, and then everything else around the cells is kind of the ground substance. Okay, and so in the ground substance of bone, we have a couple different things. These things called proteoglycans and glycoproteins. The main things that these do is they provide osmotic pressure for that area, so the bones can hold on to water. Right, so we need to keep water in our bones. Our bones are moist. Okay, and that's part of what that osteoid substance is, which is like pretty much the fluid around the cells of the bones. Okay, and then this is also where the collagen is. Right, so it's big, strong collagen fibers that give the bone some flexibility, some tensile strength, which means when we try to stretch them out, that's kind of what resists that stretching. And then that also helps us to resist twisting and stretching a bone, and allows for some flexibility while those kind of forces are being placed on our bone. And all of this osteoid stuff, which contains these components, comes from a special cell type called osteoblasts. Right? So osteoblasts are the cells in our bone that are releasing osteoid. An osteoid is it contains this stuff, right? Contains the components to make sure our bones stay moist, and contains the collagen fibers to give us the other part of that organic component of our bone. Yeah.
Glycoprotein, it's not only like stuck on the membrane.
Yeah, that's the one place we talked about it so far before this, but then this is another place here. It provides, provides that osmotic pressure to keep our bones kind of moist.
Flowing in the grass.
Yeah, it's not necessarily moving around, but it's kind of bound to some of the area. But yeah, it's not bound to membranes like cell membranes like it was before. It's more just out in the extracellular space. Yeah, good question. Okay, other questions so far? Okay, so then the other part of the bone is the inorganic part. So the other 2/3 of bony matrix is made up of these calcium phosphate salts. Okay, so these provide the stiffness and the durability of bone, right? And so then really the hardness versus the flexibility of bone is all about the balance of how much of the organic component do we have versus how much of the inorganic component do we have. And so this is what your bone would look like if it didn't have any of the organic component, right? If it was just the calcium phosphate salts, it'd be very brittle and rigid, and it would have no flexibility, and it would kind of shatter easily, right? So it's this mix of this component and the other component that gives the bone its rigidness, but its flexibility as well. Okay, so let's talk a little bit about the cells that we find inside of bones. Okay, we've got 4 primary cell types. And you can see they've all got osteo in the front, right? So osteo means bone, right? And then this suffix at the end means something too, right? So osteocytes, osteoblasts, osteogenic cells, and osteoclasts. Okay, so take a sec and just see if you can remember from the book, as well as just kind of guessing based on what the name is, which one would be which. So these are kind of the functions down here, right? And then those are the bones up there. So match those up, and then on your clickers, go ahead and send in this one, the one that would reabsorb the bone matrix. That means like break down bone. Okay, go ahead.
I like.
That was a rough third strike call on Bogarts yesterday, huh? Did you see that?
Glad I was at practice.
Yeah.
I didn't see
Yeah,
it.
I know.
It was brutal, man. Yeah.
See after the game. The
No.
players had to walk through our dugout.
Oh,
to go to
really?
their clubhouse.
No way.
It was burning.
Oh, my
It was
God.
like players and
That-
umpires face.
wow.
Yeah, it was bad.
That's crazy. I didn't hear about that. Dang. Dude.
I think it. Oh, no, it's not.
All right, go ahead and send that in if you haven't yet. All right. Yeah, looks like we got just about everybody. So yeah, about 80% of you are saying D for the one that would reabsorb the bone matrix, which is true. That is not a D, that's a B. Here we go. Osteoclasts are the ones that do that. The ones that are responsible for making the matrix. Yeah, we can just kind of go through here, each of these so you can see those definitions. Osteocytes are bone cells that are just there, and they're kind of caught up in these little spaces called lacuna or lacunae, and they're like little cells. But all osteocytes started as osteoblasts. So osteoblasts will release all that osteoid stuff around themselves and then pretty much just trap themselves in, right? It just kind of locks them in place. And then they become an osteocyte, and they're there to kind of maintain the matrix. So the osteoblasts are, I can match this up. So for making the matrix, sorry. Which cell is responsible for making the matrix? That would be the blast, which I think that was B. Maintain the matrix, that's osteocytes. And then which cells are found in membranes and produce new cells? Those would be those osteogenic cells. So those are our primary types of cells we find in bone. Osteoclasts are unique because they're one of few cells in the body that are multinucleated, right? They got lots of different nuclei there. It's because they have to make so many specialized proteins and chemicals that are used to break down that bone. Yeah, go ahead, Taya. Yeah, not so much. Yeah, I don't think so. Yeah. Yeah, I mean, osteoclasts have a unique look to them, but yeah, besides that, probably not. Yeah, go ahead, Ethan. So the osteoclasts do. These guys are stuck in their spot, and the osteoblasts don't move around a whole lot, and these ones are stuck in the membrane, but osteoclasts move around a lot. Yeah, yeah, and they can, yeah, they can, and the way they do it is pretty cool. They kind of create this like sealed off barrier where they're gonna do their work. Then they release a really low pH, which eats up all the calcium phosphate salts, and then they release all these enzymes that break down all the collagen. But it's all sealed in that one little spot, so they're very specific in the part that they're working on the bone. So yeah, it's pretty cool. Yeah. Yeah. Other questions on that? Yeah. Feel it? Order what? Yeah, so osteogenic cells are the ones that are going to then make the other cells. So that's kind of like a stem cell type of cell. And then they'll kind of turn into osteoblasts. And then the osteoblasts, once they kind of trap themselves in bone, then they just turn into osteocytes. Yeah, good question. Yeah. Okay, other questions? Okay. All right. So let's look a little bit deeper at what compact bone looks like, more on a microscopic level. And so compact bone, again, that was that bone on the outside of our cells, right? This is the dense bone. What we find if we look real close into that dense bone is this whole system called osteons, also known as the Haversian system. And so an osteon is this kind of cylinder shaped thing, and it has multiple layers of concentric circles. And you can see that the little lines going up like this, and then this way and this one, that's where the collagen fibers are. These concentric circles are called lamella, right? And so the lamella or lamellae are the calcium and phosphate, but it's each of those little overlapping circles. And so then we can see the collagen going this way on this one, and then this way on the other one, that way on the other one. So collagen's only really good at tensile strength, which is like pulling straight on its ends, right? And so if we have collagen going in a bunch of different directions, then we have tensile strength in all those different directions, right? And so that's kind of why the collagen is laid out in different directions. And then we can see osteocytes right here, right? Those osteocytes are kind of trapped in there. And then we have these little things called canaliculi, which just means like little canals. And these, because you can imagine these bones are just, or these little cells are just kind of trapped there, but they still need oxygen, they still need nutrients. And so they're connected to other cells and places where there's blood vessels via these little miniature canals. And then there's gap junctions between the cells so they can send nutrients from one cell to the next. And so all of that is kind of talked about here with those canaliculi, right? So there's there's blood in the middle of this thing, right? So that blood's got to make it to all these cells somehow, right? So it's kind of passed from cell to cell via gap junctions, via these little canals. Okay, questions on that? Okay, so this just looks a little bit closer at that, but go ahead, label those things in the compact bone here, and then which one do you think will be the lamellae? Yeah.
Okay, wait. Okay, on here, were you saying so it starts here and then it goes across?
No.
Or starts?
Osteogenic cells are the ones that start everything, and then these osteoblasts will turn into osteocytes.
So this one is different.
Yeah, it's kind of separate. Yeah,
Oh, the.
osteoclasts are separate, but these ones will kind of go this way in their formation.
Okay.
Yeah,
Gotcha. Thank you.
yeah, yeah. Hey.
I'm just wondering if these bones move around too, or is it just us?
No, the osteoclast is like from a different cell line completely, but these osteogenic cells will form osteoblasts, which then will turn themselves into osteocytes when they get stuck. So,
Okay.
but yeah.
What are the like the little like legs, I guess, for?
Yeah, good question. I don't really know.
Okay.
Yeah. I'm not sure what the legs are for, but yeah,
Thank you.
yeah. All right, send in your answer there. Which ones are the lamellae?
I'm yeah.
All right, go ahead and send it in if you haven't yet. We can walk through the answers here. So we can see how there's a bunch of those osteons within compact bone, right? And then there's a central canal in each of them, so we can see all the different blood vessels embedded in bone, right? And so, yeah, that would just be one of those central canals where we have the bundle that we have all throughout the body. And you'll see this when we start dissecting the cats, is we always have a vein, artery, and nerve traveling together, right? So we can see that the yellow one represents the nerve. Then we got vein and artery there. It's very common to see those three together. This is the osteon itself, right? C would be what are called circumferential lamellae. So big concentric circles that go all the way around the whole outside of the bone. Okay. D would be just little lamellae in within a single osteon, which was right here, right? Okay, and then E we can see that we need canals going kind of transversely across the bone too, right? We have blood vessels going this way, but then to get out to the outer parts where we have more blood vessels, we need these perforating canals, right? Which are those perforating canals. And then lastly, we have that membrane that's on the outside of all bone called the periosteum. So there's kind of multiple lamellae there as far as your answer on the clicker goes. Don't worry too much about it, but yeah, could have been this one, could have been the circumferential lamellae as well. Yeah.
So inside of the central canal, those blue, yellow, and red things, they would be called periosteum.
No,
One of the, right?
no. So the periosteum is the membrane, but within that membrane, we do have a vein. We have some veins, arteries, and nerves kind of embedded in that membrane. Yeah. Mhm. Yeah. Other questions? Okay, this just kind of looks a little bit closer at that, right? Where we can really see those osteocytes and we can see how they all connect to each other too, right? There's these little canaliculi that allow these cells to connect to each other to kind of create this system of passing of nutrients back and forth. And then we see a microscopic image. You guys saw this image in the connective tissue slides as well. But now these things might make a little bit more sense, right? Because now we can see this is that osteon, right? There's that central canal where the blood vessels are passing through, right? And then we can see where those osteocytes would be, right? And you can kind of see the little cracks in it. Those are the canaliculi, right? The little canals that allow for passing of nutrients. And so we can see kind of all of that in the microscopic image. Okay. Questions on any of that? Okay, so then just a little bit more detail about spongy bone. Spongy bone, as I already mentioned, is much lighter than compact bone. It kind of looks like it's randomly organized here, but that's not true. What has been shown with research is that this stuff will completely reconstruct itself to match the patterns of force that are placed on bone. So for example, the kind of classic example with bone adapting is the studies that were done on tennis players where they look at like their dominant arm versus their non-dominant arm. The dominant arm, the bones are much thicker, but it's not only that they're thicker, these kind of start aligning with the typical force that those bones receive. So it's pretty amazing, right? That these bones are adapting to do better against whatever forces we put against them. So yeah. And so the little interconnecting rods and plates in spongy bone are called trabeculae. We don't have central blood vessels, but there's blood vessels kind of passing around through the little holes, and then it can pass through the bony part through canaliculi. Still got osteocytes there. Okay. All right. So then just a little bit more terminology here. When we look at a long bone, I already mentioned this before, but the middle part of it, the center part of it in the shaft is called the diaphysis. Okay. So the diaphysis is this whole shaft part in the middle. Everything between these dotted lines is diaphysis. Okay. That's always going to have a collar of compact bone. And then it actually has a hole in the middle. It has an actual cavity, right? It's called the medullary cavity. And in adults, it's going to be yellow marrow. So it's going to be full of fat, pretty much. Okay, and then we have the epiphyses on the end. So both ends of those long bones have epiphyses. These are just the ends. Okay, again, we've got a shell of compact bone, just like the diaphysis, but there's no cavity on the inside. It's just spongy bone with trabeculae in the middle, and that's where we would find red bone marrow in a lot of our bones. Okay, and then we have what's known as the epiphyseal plate or epiphyseal line. Okay, and that is right here on this one. You can see them up here as well. So right here, right here. And so that is the line of growth. That's your growth plate, right? And when your growth plates close after kind of post-puberty, then your bones no longer grow and it just becomes a little line of compact bone. But it starts as hyaline cartilage, right? And that hyaline cartilage is what allows our bones to grow. And we'll talk about that a little bit more on Monday, how that bone growth occurs. But then once that closes up, it just turns into compact bone. And you can see it on x-rays a little bit thicker in that spot. So, okay. Questions on that? Okay, and then other parts of long bones that we see, again, we've always got that periosteum on the outside of our bone, which is that connective tissue layer. And then the inner layer of that periosteum is where we're going to have a lot of cells. Okay, so there's going to be a lot of osteoblasts, osteoclasts, and osteogenic cells kind of on the very inner side of that membrane. And these are kind of some of the functions of that periosteum. The endosteum is also a connective tissue layer, but it would be on the inside. So we'd find it like on the inside of the medullary cavity. There'd be another connective tissue layer here. That's the endosteum. Okay. We always have a cap of articular cartilage on the end of our long bones because that's where it's going to make the joints, right? And then again, in the diaphyses, in the spongy bone in the diaphyses, we have hematopoietic tissue, which is bone marrow, right? Tissue making red blood cells and white blood cells. And then again, in babies and kids, in that big cavity here, this wouldn't be yellow marrow, but this would be red marrow there. Okay. All right, then lastly, we look at the anatomy of the other types of bones, so flat, short, and irregular bones. We kind of think of it this way, like a little sandwich, okay? So we've got some periosteum out here on the outside. We've got compact bone here in the middle. We've got endosteum here on the inside. We've got a bunch of spongy bone in the middle, more endosteum, more compact bone, and then more periosteum on the outside, right? It's just kind of the pattern of those bones. So, okay. All right, guys, we can be done 6 minutes early. Have a great weekend. We'll see you guys on Monday. Yeah. I don't know.
Just kind of pointed to see what
Yeah.
I'm curious about. So I'm just trying to picture, like, there's so many parts.
Yeah.
But so these are, I forget what they're called. Okay, so then it is the osteo.
Here, I'll put some quick on the video.
You have to give me copyright.
Turn it off.